want to push boundaries of what you can measure at your home laboratory further to the next level.
Ragalco has been associated with rotating anode technology for decades now. A few years before I joined, the Micromex 007 series of generators was launched. And in the last 25 years, nothing's ever come close to it in terms of performance, reliability, and cost of ownership. In terms of dollars per photon, it's completely unique.
When we are talking about X-ray diffraction, single crystal X-ray diffraction, or 3D X-ray diffraction in general, it is a more and more demanding field. On the one hand, our samples get smaller and smaller. Our samples also get more difficult in the sense that the quality sometimes is very much on the edge. So you need to compensate by photon flux in order to get enough signal out to get the answer which you are requiring, let's say, to the 1 angstrom or the 0.8 angstrom resolution.
Science doesn't stand still. Our customers are constantly pushing the boundaries of what they would like to achieve at home. And so it's our responsibility to deliver equipment that will meet their requirements for the next 5, 10, 15 years. To do that, we wanted to make a step change in performance rather than just small incremental steps.
Now we are launching the PhotonJetULTRA rotating anode X-ray source, which has the feature of being able to operate at various powers while still maintaining thermal stability. We can run the source at full power, 1.2 kilowatts, or 800 watts high brightness mode, or even echo mode. And the X-ray beam will remain focused on the sample on the goniometer thanks to thermal stabilization features inside the X-ray source.
There are actually several goals that we wanted to do. We wanted to increase the performance above all because we wanted to push boundaries of what you can measure at your laboratory. The other goal is, of course, the usability, the user-friendliness, and of course the service intervals. And actually we have done this in many ways on this new X-ray source. So when it comes to the performance, because that's probably the most important for the customers, we have managed to increase the performance of the moly wavelength by a factor of 2 in terms of the flux density. We have also managed to increase the copper performance by about 30%. So from the usability perspective, we have reduced the time of the switching the wavelength. Whenever you need to switch from moly to copper, now it takes just a minute and you can start straight away doing the data collection. You don't need to wait for the stabilization of your X-ray source. And this is all achieved thanks to our thermally compensated cathode.
Thermal stability is absolutely vital for our X-ray sources. We need to keep narrow X-ray beams focused all the time on tiny crystals on the center of our goniometer. This crystal could be even 1 micrometer in size. We achieve this right now in the 007 rotating anode X-ray source by keeping the power at constant all the time. So that's 1.2 kilowatts to keep thermal stability in the whole source.
The thermally compensated emitter, which is sending the electrons onto the target, allows that the whole setup is also thermally stable from second 1 of the experiment. In the older designs, there was a certain thermal inertia, and by the new design, you can have a thermal equilibrium at very early stages and allow 100% performance after a few minutes of firing up the system.
Because we have thermally stabilized our cathode, we can operate it also at different power levels. So whenever you have well diffracting samples, you don't need this much flux. You can operate the source at the lower power level, and you can extend the lifetime of your anode. Whenever if you have a challenging sample, you go to high brightness mode or to the full power mode, and you can measure the data.
We can ramp the source down to standby power and standby rotation speed, and the user can then, for most of the week, leave the source on standby power, and when they have a crystal they need to measure, walk up to the instrument, ramp up to full power, and have it stable within a few minutes. Also, when the ultra source is in standby mode at low power, it will also slow down the anode rotation to reduce wear and tear on the moving parts. And this way, we'll extend the service interval from 1 year to 2 years for this X-ray source.
We have multi-tracking, which allows to reposition the beam focus onto a different point on the rotating drum in order to get top performance back again. If you reposition the target, you need to realign. This is done by the IOM Intelligent Optics Module automation.
The IOM is the only optics in the world which can fully automatically align the X-ray beam onto the goniometer center. So whenever you need to have the top performance, you can just click self-align and button, and it will automatically align itself.
Generally, when you are coming from a sealed tube system like our PhotonJet S sources, and you're experiencing the first time an experiment on a PhotonJet Ultra, I think you're blown away by the shrinkage of timescales for the same samples which you measured on your sealed tube system. You have more than an order of magnitude more photons available in your sample space. And this is just, it makes it possible that some samples which on a sealed tube are just impossible, are now possible to measure. They come into the reach, so extremely tiny organic crystals, 4 microns in size, you can tackle. And for the normal samples, it is like this, that of course this time factor, you can use this for throughput, or you can use that for data quality. Additionally, there are these other classes of experiments, powder experiments, for example, which you can perform on such an instrument, where also this brilliant performance is helping you to get better results. I'm also very keen on multi-grain experiments, which is basically like bad powders, which have like several hundred grains, which are in the ball of a 50 micron ball, kept in the sphere of confusion of the instrument, and trying to get simultaneously the diffraction information from many grains at the same time. Also there, such an extremely brilliant source is the key asset in combination with the low noise detectors to get the experiments which you want to get.
So this was never going to be an easy task, and many companies have tried to make a source that can compete with Rugaka rotating anodes, and they've all failed. So that's why I was particularly impressed with that our R&D team have managed to take a technology that was very well established and make a significant step change in performance. This source is something very special.